Okay, this is lesson 8.3, representing linear functions. A linear equation, such as the equation y equals 2x, is an equation whose graph is a line. A linear equation is also a function because each member of the domain, the x values, is paired with exactly one member of the range, the y values. And you can see that from this equation. Think about if you were to plug in numbers for x, there's no way you'd get different numbers for y. So like if I plugged in 1 for x, I'm going to get 2 for y. There's no way to get any number other than 2. If I plugged in 7 for x, 2 times 7 is 14. You get 14 for y. There's no way to get anything else other than that number. So there would be no way for x to be paired with something different. It would always give you just exactly one y value. The solution of an equation with two variables consists of two numbers, one for each variable, that make the equation true. So I just mentioned two solutions of this linear equation, y equals 2x. One would be when x is 1, y is 2, and the other one I mentioned was when x is 7, y is 14. So they're pairs of numbers, they're ordered pairs. So for example 1, we want to find four solutions of the equation y equals 4x plus 3, and we'll write those solutions as ordered pairs. Now it doesn't say what solutions. We can pick whatever numbers we want for x. So let's pick some easy numbers, like 0, 1, 2, and 3. Now you can pick whatever numbers you want. If you wanted to do 2, 4, 6, and 8 instead, that'd be fine. If you did 10, 20, 30, 40, that would be fine too. You could do -1, -2, -3, -4. It doesn't matter. You can pick whatever numbers you want for x. What we want are the corresponding numbers for y that make this ordered pair a solution of that equation. So there's space here for you to substitute the values you pick for x. So when x is 0, we have y equals 4 times 0 plus 3. And when we evaluate that, 4 times 0 is 0, plus 3 is 3. So the first ordered pair is 0 for x, 3 for y. So that's 0, 3. When x is 1, we have y equals 4 times 1 plus 3. And 4 times 1 is 4, plus 3 is 7. So this ordered pair is 1, 7. When x is 2, we have y equals 4 times 2 plus 3. 4 times 2 is 8, plus 3 is 11. That's 2, 11. And when x is 3, we have y equals 4 times 3 plus 3. 4 times 3 is 12, plus 3 is 15. So that's the ordered pair, 3, 15. Now there are lots and lots and lots of ordered pairs that are solutions of this equation. This is just 4 of them. So those are all solutions to the equation y equals 4x plus 3. Those are some of the solutions. Those are 4 examples of solutions. Okay, so for the try it yourself problems, remember again, you can choose whatever numbers you want for x. You're just finding solutions of each of those equations. So go ahead and work through those, pick whatever numbers you want for x, figure out the corresponding numbers for y. When you hit play to continue watching the video, I'll give you some examples of solutions, but remember that yours can be different. So go ahead and pause the video, work through those 2 problems, come up with 4 solutions for each one, and then when you're ready to check your answers, go ahead and hit play to continue. Okay, so for the first one, the x values that I chose, remember you could have chosen something different, the x values I chose were 1, 3, 5, and 7. And the y values I got that went with that were 3, 5, 7, and 9. So that gave me the ordered pairs 1, 3, 3, 5, 5, 7, and 7, 9. Remember, you could have gotten something different, but these are just 4 examples of ordered pairs. So as long as your ordered pairs fit in this equation, whatever ordered pairs you have are fine. For the second one, the numbers I chose for x were 2, 4, 6, and 8. And the y values I got as a result were 1, -3, -7, and -11, and that gave me the ordered pairs 2, 1, 4, -3, 6, -7, and 8, -11. And again, you can have different ordered pairs, that's fine. These are just some examples. Okay. For example 2, we have an actual situation that's represented by an equation. So this says that a local software company, level 1 employees earn $48,000 and level 2 employees earn $24,000. If X represents the number of level 1 employees and Y represents the number of level 2 employees, find 4 solutions of 48,000X plus 24,000Y equals 216,000 to determine how many employees at each level the company can hire for $216,000. Explain each solution. Okay, so again, we can pick pretty much whatever numbers we want for X. So let's start with something easy. Let's say X is 0. Because it would be possible, this is the number of level 1 employees, it's possible that the company could hire no level 1 employees and just employ level 2 employees. So when X is 0, the equation 48,000X, which is 0, plus 24,000Y equals 216,000. And when we solve this for Y, this one's not nearly as straightforward as these other two equations where you have Y equals something. So this one's a little bit more tricky. I'm going to show you just a refresher on how you would solve this for Y. But I'm not going to continue working out each of the other ones. The work should be similar for each one. So we'd multiply 48,000 times 0. In this case, this will just become 0. So all we're left with on the left side is just 24,000 Y, and then equals 216,000. And from there we would just divide by 24,000. And that would give us Y equals 9. Which is the ordered pair 0, 9. And what this means, because X is the number of level 1 employees, that means there are 0 level 1 and 9 level 2. And that solution would make sense with this problem. It's possible that the company could decide to spend all their money on hiring just level 2 employees, in which case they would have 0 level 1 and 9 level 2. That's fine. Let's find another solution. Let's say now X is 2. So we'd have 48,000 times 2 plus 24,000 Y equals 216,000. And again, you should know how to solve this equation, but just a refresher, you'll need to first multiply 48,000 times 2, and then we'll subtract that from both sides to get the Y, to start to get the Y by itself. So multiply 48,000 times 2, subtract from both sides, and then you should have 24,000 Y equals something, and then we'll divide by 24,000. If you've solved that part of the equation correctly, the value for Y that you should get should be 5. So that gives you the ordered pair 2, 5. And again, to explain that solution, that would be 2 level 1 employees and 5 level 2. And that's also a reasonable solution for this problem. Okay, let's try another one. Let's try 4 level 1 employees. So we have 48,000 times 4 plus 24,000 Y equals 216,000. And again, we'll multiply 48,000 times 4. We'll subtract that from both sides, and then divide by 24,000. And again, if that's solved correctly, we should end up with 1. So this is the ordered pair 4, 1. And that means there would be 4 level 1 employees and 1 level 2 employee. Okay, we need one more solution. So let's see what happens when we have 6 level 1 employees. So 48,000 times 6 plus 24,000 Y equals 216,000. And now for this one, when we multiply this times 48,000 times 6, subtract that from both sides, and divide by 24,000. If you did this correctly, you should come up with -3. So that would be the ordered pair 6, -3. Well, that's kind of a problem because this says that we would have 6 level 1 employees and -3 level 2 employees, and that's not possible. You can't hire a negative number of employees. That would be basically employees paying you to work, and that does not make any sense at all. So, in this case, this solution is not reasonable for this particular problem. So this is not a valid solution. It is a solution to the equation that represents the problem. However, the solution itself does not make sense in the context of the problem, so it's not a valid solution. Now, if we wanted to find another solution, a real solution that is valid, we could pretty much choose anything between 0 and 4. So we could try 1, we could try 3, because we know if 0 employees is okay and 2 employees, level 1 employees, is okay, well, 1 should be as well. Same thing with between 2 and 4, because those were both valid solutions. 3 would also be a valid solution. So you could choose either of those to check to find one additional solution. But this last solution here is not a valid solution because basically the problem is you don't have enough money to pay 48,000 or 6 employees, level 1 employees, 48,000 each, because you'd be over 216,000. Okay, so there's a similar problem on the back of this page, the try it yourself problem. And in this case, if you read this, it says to find 2 solutions of this equation. And I've left you enough space for 4 solutions, just in case you find one that's not an actual solution. So go ahead and pause the video, work through that problem, and when you're ready to check your answer, go ahead and hit play. Okay, for this one, there are only 4 valid solutions, so you should have 2 of these 4 solutions. You could have come up with 1, 7, 2, 5, 3, 3, or 4, 1. Any 2 of those 4 is okay. You didn't have to have all 4 of them, but those are the only 4 solutions that will work with this problem. And for each of these, the first number is the number of burritos, and the second one is the number of tacos. So this would be 1 burrito and 7 tacos. This would be 2 burritos and 5 tacos. 3 burritos and 3 tacos. Or 4 burritos and 1 taco. Okay. Alright, so the solutions in example 2, both in the example and the try it yourself problem, represent discrete data because only whole number values are appropriate. We couldn't order 2.5 burritos, for example, and you can't employ 3.7 employees. So those are discrete data because only whole number values are appropriate. The opposite of that is continuous data. So you see the comparison here. For discrete data, only whole number values are appropriate, versus with continuous data, those can take on any value. Discrete data has space between possible data values. Continuous data has no space between data values. So some examples that you can see are kind of similar. Discrete data would be something like the number of fish a tank can hold. Again, you can't have 2.3 fish. So you could have 2 fish, you can have 3 fish, but nothing in between. In comparison, the size of fish in a fish tank, if you're measuring the size of fish, those could be any measurement possible. So it wouldn't have to be whole numbers. Also, the number of shirts you can buy is another example of discrete data. You could buy 3 shirts, you could buy 4 shirts, you couldn't buy 3.8 shirts. But the cost of a shirt is continuous. That can take on any value, any dollar value. Okay. One thing that you can use this whole idea of finding pairs of x and y values for, one thing you can use that for is to actually graph a linear equation. And one way to do that is to look at the x-intercept and the y-intercept of those graphs. So the x-intercept is the x-coordinate of the point at which the graph crosses the x-axis. And you see that in this line is right here at 5, 0. At this point, y value is 0. So we see that on this graph, this is the point 5, 0. That will always be the case on whatever the x-intercept is. It will always have a y value of 0. Similar to that, the y-intercept is the y-coordinate of the point at which the graph crosses the y-axis. And that's this point on this graph, 0, 4. At this point, the x value will always be 0. Since 2 points determine a straight line, a simple method of graphing a linear equation is to find the points where the graph crosses the x-axis and y-axis and connect them. Because substituting 0 for x and y is very, very easy to do, that makes it very, very easy to graph equations this way, because you can easily find those values. So let's see what this looks like. For number 3, we want to graph the equation y equals x plus 2. We're going to do that by creating a table and finding the intercepts. So we know one of the intercepts, the x-intercept, is the x-coordinate of the point at which the graph crosses the x-axis. And we know at that point the y value is 0. So we know if we substitute 0 for y, we should be able to find the x-intercept. So if we take this equation and we substitute 0 for y, we get 0 equals x plus 2. And we all know how to solve this equation. We'll subtract 2 from both sides, and we get that negative 2 is equal to x. So that means when y is 0, the x value is negative 2. We'll do the same thing to find the y-intercept, only now this is where the x value is 0. So we'll plug in 0 for x, and we replace the x with 0, we have y equals 0 plus 2. And 0 plus 2 is just 2. So then the y value is 2. And we can use these two ordered pairs to plot on the graph and then connect them to make a straight line to graph this equation. So negative 2, 0. If we go to the left 2, don't go up or down since it's 0, is right there. And then the y-intercept of 0, 2, don't go left or right since it's 0, we go up 2. And those are the two intercepts for that line. So we'll just connect those with a nice straight line. And make sure for these that you're using a ruler or the edge of your protractor or something like that to make a nice straight line. Don't just draw it with a pencil. Make sure you're using something to make sure that that's straight. Okay, so that's what that straight line looks like. And remember that this is just another representation of this linear function, the function y equals x plus 2. We have a table showing a couple of the ordered pairs. We have the equation showing the relationship between the two variables, and this line is also a representation of that same function. Okay, we're going to do the same thing for the try it yourself problem. You want to find the two intercepts, the x and y intercepts, plot those points, and then draw a straight line to represent this equation. So pause the video, create that line, and then when you're ready to check your graph, go ahead and hit play to resume. Okay, so the two intercepts you should have gotten should have been an x-intercept of 4 and a y-intercept of negative 4. So your graph should look like this. Should have an x-intercept of 4, a y-intercept of negative 4.